Okay, today we're going to start graphing polynomials. So we're going to first review a little bit about putting polynomials in standard form and deciding the degree. The degree and the leading coefficient is going to be really important when we go to graph. So the first one is in standard form. My degree for this is 5. And the leading coefficient is going to be 3. So remember that those two things are going to be pretty important. The next one is not in standard form, so we're going to first put this in standard form. 2x4 goes first. And my degree is going to be 4, which is even. And my leading coefficient is a positive 2. So these two things are going to be important. So for the next one, this is A and B are in standard form. This is in intercept form, which is also good. To find out what the degree is when it is in standard form is you are going to count the number of x's. So what we're going to do is make sure that every one of these factors have their own exponent, and you are going to total up the exponents. So my degree would be 4. And the leading coefficient is going to be 1, which it is going to be positive, and this is going to be even. So these are your explanations for standard form and intercept form. What we're going to do next is we're going to determine the end behavior of a polynomial. Without graphing, you should be able to tell what your end behavior is by looking at the equation, whether it's in standard form or intercept form. So these are the two things that we have to look at. We're going to look at our coefficient, and we're going to tell whether if it's positive or negative. And we're also going to look at the degree. And for the degree, you want to know if it's going to be odd or even. So when we're looking at this little chart, it's going to help us with what our end behaviors are going to look like. So if we're looking at a positive leading coefficient, we're going to look at the degree being odd or the degree being even. Those are the two possibilities. So we're going to think of the lowest possible function when it's odd, and that would be a linear function. So if we were to draw the parent function, we know that our graph is going to look like this for the parent function, but all we are concerned about is looking at our ends. So with an odd function and the leading coefficient is positive, when x approaches positive infinity or the right, our end behavior will always face up or positive infinity. When it is approaching the left side, then our end behavior is going to be negative infinity. When it's even, our lowest even degree is going to be x squared. Well, we know that that's a quadratic, and we know that we're going to end up with a parabola that faces up. So as it approaches to the right side or positive, it faces up, and even when it approaches the left side, it's positive. This is when the leading coefficient is positive. Now we're going to look at the same thing, odd and even, but this time our leading coefficient is going to be negative. So for our first one, our lowest odd is going to be negative x, which means that this is going to be a line that is falling. So as it approaches the right side, our y approaches negative infinity, and as it approaches the left, it approaches positive. So again, remember, we are only concerned about the ends of the graph. This, our lowest even, is going to look like this. That means it's going to be flipped over, and both of our ends are going to be facing down. So this chart you can apply to any degree. It does not have to be a 1 or a 2. So I'm going to kind of summarize it, and it's going to look like this. So if we have positive coefficient, we have a negative coefficient. We have an odd, and we have an even. If you have an odd positive, then my ends are going to face in opposite directions. So it's going to look like this. The ends are going to look like that. It doesn't matter what goes on in between the two ends, your ends are going to be facing in opposite direction. If it's an even positive, they're going to be both facing up. So odd means that it's facing, the ends are facing in an opposite direction. Even, they're going to both be facing the same direction. So if it's an odd negative, it's going to start high and finish low. A negative even or even negative, they're going to both be facing down. Those are your ends of your graph. We do not care what's happening in the middle. So we're going to determine the end behavior of the function. The first thing we want to do is make sure that it's in the correct form. This is standard, so you have to go descending. So our leading coefficient, that is going to be negative. It's a negative leading coefficient, and the degree is 5, which means it is odd. So what we have is an odd negative function. So since it's odd, we know that it's going to be facing opposite directions, and since it's negative, it's going to start high and finish low. So our end behavior is going to be, as x approaches positive infinity, y approaches negative, and as x approaches negative, y approaches positive. I would suggest that you draw that to remind you what your graph is going to look like, your ends are going to look like. This is in factored form, so we want to make sure everything has their own exponent. My degree is going to be 2, 3, 4, which is even. And our leading coefficient is 1, and it is positive, which means that both of my ends are going to be facing up. So as x approaches positive, y approaches positive. As x approaches negative, y approaches negative. So I think it's helpful to put this. I also think it's helpful to write out what your leading coefficient and your degree is. So remember that we are determining some of this information without graphing. We're looking at only the equation. Okay, so in a polynomial function, there's 3 things that can happen. We're going to, and this is all determined by the degree. So if it is equal to 1, something is going to happen. If it is odd, the degree, if the degree is equal to 1, if the degree is odd and greater than 1, or if the degree is even. 3 things can happen. If it is odd, the graph will cross the x-axis at that point. Right here, this is odd and equal to 1. So this, what's going to happen is going to cross. If it's odd and greater than 1, it is going to wiggle and cross. And if it's even, it's going to bounce. So think of the first one, if it's equal to 1, so that means that if it's f of x equals x, we know that it's just going to cross through 0. And your x-intercept is 0. Think of, on your even, think of a quadratic. And on a quadratic, my x-intercept is 0. Well, when it gets to 0, it's going to bounce, and it's going to return and go in the same direction. So what we're going to see, the only one that you haven't seen is your odd greater than 1. Well, actually, we have looked at that because we talked about a cubic function. That's your lowest odd greater than 1. And what happens is that your y-intercept is 0. And when you get to that, you're going to wiggle and you're going to cross. It's going to bend and cross. So what we're going to do here is we're going to find the x-intercepts, and we're going to decide what it does at each one of those points. So this first one, you want to give everything their own exponent. Well, at x, my x-intercept is 0. X plus 4, my x-intercept is negative 4. And x minus 3, my x-intercept is 3. Excuse me. At 0, your multiplicity is the same as your degree, or your exponent. The multiplicity is referring to the degree. At 0, your multiplicity is 1. That means it's going to cross at 0. At negative 4, your multiplicity is 1. That means it's going to cross at 4. Negative 4. At 3, our multiplicity is 2, so that means it is going to bounce. So that's all it's asking for. You could draw a very rough graph. Your x-intercepts is 0, negative 4, and 3. So we know that this polynomial is an even degree with a positive coefficient, which means that both of our ends are going to be facing up. So it's going to be coming from the top. So it's going to come from the top, go through 0, go to 3, bounce, and return. That's what your graph is going to look like. What we don't know, this is not an exact graph, this is just a sketch. What we don't know is where these turning points are. That's what makes this a sketch and nothing more. If we wanted exact points for those turns, you would have to build a table. Okay, the next one. So we have, I'm going to give this a 1. We have 3 x-intercepts. We have 0, we have 7, we have negative 6. The degree at 0, because if I take negative 2x to the 5th, set it equal to 0, that's how you find in all of them, and solve for x, you're going to end up with x equals 0. So at 0, the degree is 5, so that means it is going to wiggle and cross. At 7, it's even, so that means it's going to bounce. And at negative 6, it is 1, it's going to cross. This is 5, 7, 8. This degree is even, and our leading coefficient is negative. That means our ends are going to face down. So this would be 0, 7, negative 6. So if it's facing down, it's coming from the bottom first. It's going to bounce or cross at negative 6. It is going to wiggle and cross at 0, and it's going to bounce at 7. That's our graph. Okay, so we're doing the same thing on these. We're going to sketch. In order to sketch, you need to get your x-intercepts. You need to find out what kind of polynomial it is, whether it's even, odd, or positive or negative. So I'm going to do that first. I'm going to give everything their own degree. I'm going to add up my degrees. That would be 5, 6. That means this is an even polynomial. The leading coefficient degree is even. The leading coefficient is negative, which means that my ends are going to face down. My x-intercepts are 2, 5, -1. At 2, it is 3, so it's going to wiggle and cross. At 5, it's 2, that means it's going to bounce. And -1, it's going to cross. So 2, 5, -1. So it's coming from the bottom. It's going to cross at -1. It's going to wiggle and cross at 2. And it's going to bounce. So there's our graph. Give everything an exponent. Add up your degrees. That's 7, 8. That means the degree is even. Your leading coefficient is positive. That means that my ends are going to both face up. My x-intercepts are 0, 1, -2. Zero, 1, -2. So coming from the top, at 0, it is going to bounce. At 1, it's going to wiggle and cross. -2, it's going to cross. So at -2, we're going from the top, go through -2. At 0, it's going to bounce. At 1, it's going to wiggle and cross. Okay, when you get something like this, the first thing you have to do is you have to factor. So we have, this is an odd degree, and it is positive. So that means that my ends are going to face in opposite directions. It's going to start low, finish high. My x-intercepts are 0 and 2. At 0, it's going to bounce. At 2, it is going to cross. 0, 2, starts at the bottom, bounce at 0, cross at 2. I'm going to take out my x cubed. I need my negative. I need to take that out as well. So this would be negative x cubed, x minus 2. This degree is even, and the leading coefficient is negative. So that means that my ends are going to both be facing down. My roots are going to be 0 and 2. 0, 2. It's going to be coming from the bottom. At 0, it is going to wiggle and cross, and at 2, it's going to cross. So it's going to wiggle, cross, 2, it's going to cross. Okay, this one I'm going to factor. So this is going to be, factor out that x. Factor, this would be 18. I need to split the middle. Okay, so all I did was factored. Hopefully by now you can do that. So this is a degree of 3, which is odd. Leading coefficient is positive. My roots are 0, -3/2, and 3. At 0, all of these are going to cross. So this would be 0, 3, -3/2. My graph is odd and positive, so that means it's going to start low and finish high. It's going to cross on all of these. And that's my answer. I'm going to factor. So this would be factors of 36. That would be 9 and 4. X squared minus 9. Which means x minus 3, x plus 3, x minus 2, and x plus 2. You can look at your highest exponent. That can tell you the possible max number of roots. And so for this one, we have 4. Those are our x-intercepts, and they all are at 1, degree 1, so they're all going to cross. And this degree is 4, that's even, and leading coefficient is positive, so that means that both ends are going to face up. So we have 2 and -2, 3 and -3. We start high, and there's our graph. So I haven't been putting the, let's see. Yeah, it didn't ask for the end behavior, but this is as x approaches positive infinity, y approaches positive. And that is how you graph them. Remember, these are sketches, not a graph. So look right here, it says sketch a graph. Okay, so when we're going to sketch a graph with the different characteristics. I think it's easy, or it's helpful if you use your highlighter. For some of these, it says f is increasing on the intervals from -infinity to 0. So if it's increasing from -infinity to 0, something is going to happen at the 0 mark, and then it's going to increase from 4 to positive infinity. It's going to decrease between 0 and 4. So on the next one, it says that f of x is greater than 0 in the intervals between -2 and 3. So that means between -2 and 3, if it's greater than 0, it has to be above the y-axis. So between -2 and 3, it's going to be up here. So I'm going to highlight that. And then between 5 and positive infinity, it's going to be up here. And then between negative infinity to negative 2, it's going to be below. So it's going to be down here. And then 3 to 5 is going to be down. So that means that for me, I know that where my highlighted area is, that's where my graph has to be. So now go back and it says it's increasing from negative infinity to 0. So I can start anywhere. So if I start here, it's got to be increasing, increasing. Now it's going to shift over into the yellow, and it's going to keep increasing until you get to 0. So anywhere there, it doesn't matter. And then at 0, it's going to start decreasing, but I'm still in the yellow. So I keep going, decrease, now I'm in the orange, and I go to 4. And now I'm going to start increasing again because it says from 4 to positive infinity, but I'm going to stay in that orange until I get to this yellow, and then I keep increasing. That's my graph. So since my ends are facing opposite directions, I know that this is an odd graph. That's the degree, and the leading coefficient has to be positive because I started low and finished high. Okay? All right, we're also going to check to see if our function is even and odd. That does not, even and odd functions are not the same as your degree is even or odd. Don't confuse that. If you want to know if it's an even or odd function, it's not the same as the degree being even or odd. To tell if it's an even or odd function, what you're doing is checking for symmetry. So what you're going to do is you are going to replace the x in your equation with a negative x. If the equation stays the same, it is going to be an even function, and it'll be symmetrical to the origin. If all of the signs change from your original problem, then it is going to be an odd function. If it's a mixture, it's going to be neither. So if I take f of x and replace it with a negative, then I come over here and replace x with negative. And then I simplify my equation. Negative x cubed, that makes it negative x cubed. And then this would be plus 7x. I am comparing this to my original equation. Well, all of the signs have been changed. So that means that this graph is going to be an odd function. So this, you replace your x with a negative. You go to your equation and you replace all of your x's with a negative. And then you simplify. So this would be x4 plus x squared minus 1. You compare this to this. If the signs did not change, which they didn't, that's going to be even. I'm going to replace x with a negative. I'm going to simplify. This would be negative x cubed plus 2. And I'm going to compare this one to this one. The negative x cubed changed, so this changed, but this did not. It stayed the same. So it's a mixture of changing and staying the same. This is neither. And that is our lesson over graphing polynomials.